Example 1.27. Consider the function f of x, which is x minus 1 divided by x squared minus 1. And let's talk about two different limits. One is going to give us a removable, or one is going to exist, resulting from a removable discontinuity. The other limit will not exist because it is a non-removable discontinuity. So let's work on the removable one first. The limit as x approaches 1 of the function. Let's just tell ourselves what the function is. F of x is x minus 1 over x squared minus 1. And if we try direct substitution, our numerator is a 0, our denominator is also a 0. So we know we're going to have to play around with this a little bit. Let's try to factor. That denominator can be rewritten as x minus 1, x plus 1. There's your cancellation. This now becomes just 1 over x plus 1. And from direct substitution, when x gets sent to 1, you have 1 plus 1 in your denominator. The limit is equal to 1/2. Right, so that y value right there is 1/2. The function does not exist there because if x was equal to 1, you would be dividing by 0, which is not allowed. But the limit does exist because we were able to remove the discontinuity, right, through that cancellation. Let's now work on the second limit, the limit as x approaches minus 1 of the function. So let's just copy everything down, remind ourselves what is f of x. It is x minus 1 over x squared minus 1. Again, with direct substitution, what do we get? We get minus 1 is a minus 2. And our denominator gets sent to 0. So that is not that indeterminate form. Right? If you looked at the function's factored form, x minus 1 over x minus 1, x plus 1, you get cancellation of the x minus 1s, but the x plus 1 factor is still in your denominator. So when you send x to minus 1, this factor is going to approach the value of 0. So the value of this function is going to explode to either positive or negative infinity. That's what we get here on the right-hand side to positive infinity, on the left-hand side to negative infinity. This is not a real number. The limit does not exist.